6 volts, okay.
We have 300 ohms here. Now 1,000. I'm just making numbers up here. Uh, 500 ohms. Since I'm making numbers, I have no idea how small this value is going to be. This is 0.2 times Vx. I'll define Vx in a second. $1,000, 1K, and 2K, 2,000. And Vx, I'm going to define it on the top, plus to minus. Now I'll make the question, find Vx. I see a couple of things I can do quickly. What do you see? Combine these, good, on that end. And what else? Source transformation here. So maybe I'll do both of these. This will be a current source. I equals V over R, 6 divided by 300. And what do we have? Is that 0.02? In parallel with the 300 and the 1,000 here. As I said, when you make numbers up, sometimes because I wish I picked a different number. That's 0.2 Vx. Vx still good. I didn't damage it yet. And we have the product over the sum. 2 divided by 3 is at 667 roughly. These two guys in parallel. I can do 300 times 1,000 divided by 1,300. 231. As I said, you start making numbers, your number is going to be funny there. Okay, yep. You want to do what, source transformation? I can do that, and I can do one here too.
So you can do those three divine sources.
We just did that in the previous one, yeah? Yep, top one. Remember that one? Uh-oh. Now I get me messed up here. I think I flipped the pages in the wrong direction. No, they're good. Okay. Let's see. This one's going to be a voltage source pointing upward, plus on the top, minus on the bottom. 0.02 times 231. 4.6, 4.615, how about 4.62? $231, 500. This is Vx. Now I can put that resistor here, 667, and I can notice the arrows here go from the bottom to the top, so it's plus on the top, minus on the bottom. Of the value of that, what's 0.2 times 667?
133.4.
Yep, 133.4 Vx. 0.2 times 667. V equals I times R. Thank you. I can take this resistor and this, put them together. It doesn't affect Vx. So if I take the 231, 667, 231 plus 667, that will give me one resistor of 898. $898, 500. Oh, that's a dependent source, wasn't it? Yep. Sorry, that was a dependent source. And this is 133.4 times Vx. And again, this is Vx. So if I define my current going this way, this is I, then what is Vx equal to?
Oh, 500.
Yep, 500 times I. So if I do KVL right here, it's only one loop. Minus 4.62 plus 898 times I plus 500 times I plus 133.4 times Vx, and Vx is what? 500I equals 0. How many unknowns in that equation? 1. So 4.62 equals 500 times 133.4. Add to it the 500. Add to it the 898. And with these stupid numbers I used there, 68,098 times I. What is I equal to? 4.62 divided by that number, which is 0.68 microamps, is 6.78 times 10 to the negative 5. Actually 67, right? Not 60. So that would be 67.8 times 10 to the minus 6. That's microamps. Yeah, it's going to be a tiny voltage. So what's Vx? 500 times 67.8 micro. And we got what? 0.034. Tiny voltage. Not a bad way of doing it, actually. That source transformation is a very popular way because you can drop a lot of equations if you do color source transformation. even if you didn't do it from top to bottom, even if you did just color source transformation like here, you could have stopped here, 1, 2. And you could have done what? Nodal analysis, 2 nodes. If you decide to do a mesh equation, you know what this current, 1, 2. 2 equations by 2 unknowns instead of 4 by 4. If you start from the top, you know this, there's 1, there's 2, actually there's 3. That's all you have to start with. Okay, so that's source transformation. We also have color mode techniques. Well, actually, we only have one more technique, and that's Thevenin. And after Thevenin, we do Norton. But Norton is nothing more than Thevenin with source transformation done to it. What Thevenin said, I'll wait on that actually till the next video, next class. And I'll do that separate.